Yeah, so a nice question here, where we have to work out the logic gate control system for the monorail transport system shown. The system is powered by an onboard electric motor and includes a magnetically operated limit switch at the end of each rail. Okay, so we've seen this before, okay, where you flick a switch and the motor travels, you flick a switch the other way and it goes back the other way. This is the double pole, double throw, forward and reverse circuit.
So that circuit makes it turn anti-clockwise. So we put a limit switch on there and there. And when you press the switch, triggers the button and stops the motor.
And this one has limit switches built into the circuit, attached to the motor, and it cuts off the current to that motor. Okay. Yeah, and they're magnetically operated here. Okay, so it's not the normal limit switch. Okay, but it does the same thing. The control system uses the digital logic system below. Okay, so slide switch. Here's our slide switch or the double pole switch, and forward and back. So when the switch is forward or back, we get a logic level of 1. So just like any switch, when it's in a position for on, it is 1, or else it's 0 off. The slide switch in center position off. So 1 on, 0 off, high and low. The limit switch open, logic level 0. So when the switch is open, we have 0. So when our limit switch or when our carriage is not in contact with the limit switch, our limit switch is 0. When our carriage is in contact with our limit switch, we get a 1. So we have to write in our logic gates here, and they've given the layout for the system here.
Logic gates can be combined in different ways to produce complex circuits, often containing thousands of gates. Here we will look at 5 gates, which is enough to solve many complex circuits. A NAND gate. AND gates only work when both of them are high. Nothing there, nothing there, and now it's high. And I've made a simulation here with the lamp too, so we can watch that. An AND gate with 2 input switches only works when both of them are connected, or both are high. And with an OR gate only works when one or the other one or both inputs are high. So there we see, it's gone high already, or both, still high. And our circuit over here of the lamp will work when one or the other one or both are high.
Needs to be on for the carriage to work, so we'll have a 1 here. So we want a 1 here, and we want a 1 here. Okay, to make the motor move. Okay, what we need to do is figure out what gate and what to put here. So what gate at A to give us the correct outputs through here. So our output's going to be inversed, and to give us what we want here. Okay, so we're looking for 0 and 0. So let's have a look at the circuit with a control system here. Okay, yeah, everything is off there. We want our carriage to move, okay, when it is not in contact with our limit switches. Okay, we want 0 here. We want 0 here and 0 here. And we want our switch to be on. So when our switch is on and our limit switches are not in contact, our motor should turn on. Let's have a look here. There we go. So switch on, carriage is not in the middle, and our motor is on. Now when our motor is on, it's moving. And when it moves, it's going to flick off a limit switch when it gets to the end of the rail. And now the motor goes off, you see? So let's do it again. When it hits off another limit switch, the motor goes off. So this is a good logic system here. This is the solution that we're looking for. OR gate for gate A, an AND gate for gate C, and gate B is our NOT gate here. Okay, so why did I choose the OR gate and the AND gate? Well, I chose the OR gate here because I want the motor or the carriage to stop when it makes contact with one or the other limit switch. Okay, so one or the other one, because not both. It can't contact both. So one or the other one. So I chose an OR gate here. Okay. Now the problem is the OR gate um, gives us high here. Okay, um, which is no good for an AND gate, because that would mean that the motor would come on if that was directly across here. If there was no NOT gate, it would mean the motor would come on when it's in contact with the limit switch. Because remember, the limit switch is high or in goes to a state of 1 when it's in contact with the carriage. Okay. Remember, we want zeros here. Okay. When our limit switch is not in contact. All right. So I chose an AND gate here because I only want the motor or the carriage to travel when the double pole double throw switch is on and neither of the limit switches are triggered. So that's why I have an AND gate here. Okay, because an AND gate only goes high when one and the other one input and the other input are high too. Okay.